Let's work through the free response section of the project where you are graded for the steps you show. All right, so make sure you show all your work when working through these problems. So it says here, use properties of logarithms to expand the logarithmic expressions as much as possible, and where possible, evaluate logarithmic expressions without using a calculator. All right. So the first question is log base 8, and then within brackets we have 8 times x, right? So this is the product rule that we must apply. All right, because we have 8 multiplied by 6, correct? So let me pull up my pen here. 8x means 8 multiplied by x. Therefore, there's multiplication involved, so we have to apply the product rule of logarithms. That means we can split up the 8 and x and write it as 2 terms using log base 8. So that means we will write log base 8 of 8 and then plus log base 8 of x, right? Now we have to see if we can simplify this further. Log base 8 of 8 is a 1, right? And then we have, for the other one, log base 8 of x. We cannot simplify this because we don't have a value for x. So the answer is just 1 plus log base 8 of x. That's the final answer. Okay. Now this one, there's division involved. So this is a quotient rule that we must apply. So we have log base 3 of 3 divided by x. All right. So in this case, we will be subtracting the terms. All right. Here we added the terms. We split up 8 times x and wrote it as 2 terms, 2 separate terms, but we had a plus in between because of the product rule. This is quotient rule, so we have to rewrite this as 2 separate terms using log base 3 for each term, but there has to be a subtraction sign. All right, so let's do that here. Log base 3 of 3 minus log base 3 of x. All right, so because of this division, we have a multiplication, we have a subtraction, a minus in between the 2 terms. So now let's see what we can simplify here. Again, same thing, we have the base of the log and the argument of log, the same value. So log base 3 of 3 is a 1 minus log base 3 of x. We have to just leave it this way. We cannot simplify this any further. What do we have for the next one? Now this is a natural logarithm, ln. What is the base of a natural logarithm? It's e, correct? So ln is the same, is the equivalent of log base e. Okay, so just remind yourself, because the base is not visible when we write it as a natural logarithm, ln, in the ln form. But let's see how we can expand this expression here. So this is also division involved, e to the power 4 divided by 15. So there has to be a minus sign when we write it as separate terms using ln. So I'm going to do that. I have ln e to the power 4 and then minus ln of 15, right? Now look at the first term, ln e to the power 4. There was something called the power rule that we can apply on this. So whenever there's a power, whenever we have a power or an exponent, so to speak, then we can use another power rule which is 4. We can multiply ln of v by this 4. So that means we can bring the 4 to the left side of ln e and write it as 4 times ln of e minus ln 15. All right. Now what is ln e? We said here ln is the same as log base e, correct? So this is like writing log base e of e. So here we see the base and this value that we have next to log base e are the same, correct? So log base e of e will be a 1, right? It is equal to 1, just like it was in this previous example. Log base 8 of 8 was a 1, log base 3 of 3 was a 1. Similarly, log base e of e is also a 1. But you just have to remind yourself that ln is the same thing as log base e, right? So it'll be 4 times 1 minus ln of 15. So we will have 4 minus ln 15. All right. Now, ln 15 can be written as 4 minus ln 5 times 3, correct? So we can further split this up and write it as 2 terms. So it can be 4 minus ln of 5 plus, all right, because this is a multiplication, we have to write it as ln of 3. Now that is the complete expansion of this expression in part C.
Now I just want to say one more thing about this part C. Over here, when we wrote it as 4 minus ln of 15, right, in this step here, when we wrote it as 4 minus ln of 15, that was fine. However, when we split it up further and write it as 2 terms, all right, the second term, when we split it up further using the product rule, it's very important that we surround this with brackets, all right? This minus applies to this entire term, and when we are splitting this entire term, make sure you are surrounding it in brackets, and that this minus will need to be distributed to both the split terms of the second term. All right, so just make sure that you either surround it in brackets or you distribute this minus sign and write it as 4 minus ln 5 minus ln 3. All right.
Now question number D is log base 5 of the cube root of y. So we have a radical here, but whenever there's a radical, we can always rewrite it in exponent form, right? And once we have an exponent in a logarithm, we can use the power rule and expand the expression. So let's do that. I'm going to write log base 5, and I'm going to write the cube root of y as y to the 1/3, right? And now that we have an exponent of 1/3, we can rewrite this, apply the power rule and rewrite it by multiplying log base 5 of y by the exponent, which is 1/3. So that would be 1/3 log base 5 of y. All right, and that's how far we can go with this problem. Question number E, log base 8 of 64 divided by the square root of x plus 1. All right, so this is a division here, so we can apply the quotient rule, correct? 64 divided by square root over x plus 1 is a fraction, so we will use the quotient rule to expand this. So remember, with the quotient rule, there is a minus sign in between the two terms, So it will be log base 8 of 64 will be the first term, and then a minus, and then log base 8 of the square root of x plus 1, right? Now, log base 8 of 64 evaluates to a 2, right? Because I'm doing this on the side. In order to evaluate a logarithm, it's best to use the exponent form, all right? Change it to exponent form, and then it'll be easy for us to do the evaluation. So log base 8 of 64 means 8 raised to what power would give us a 64? 8 squared is 64, 8 to the power 2 is 64, and that's how I got the 2. And then we have a minus log base 8. Now let's look at this expression. Square root over x plus 1. Now, x plus 1 is a unit, all right? X plus 1 is a unit, so it's best to surround it with brackets to remind you that we cannot break this up. It has to go as a unit. So we can write this, however, as log base 8 of x plus 1 raised to the power half. What I just did was I rewrote the square root radical in exponent form. And once we got that, the exponent of half, we can apply the power rule and multiply log base 8 of x plus 1 by the 1/2. So we write it as half times log base 8 of x plus 1. Right, and that completes this problem. Now let's finish off question number 1 by completing part F. Now this problem is going to be a little bit different from the ones that we worked before, because previously we were using the properties of logarithm to expand the different expressions given to us. For this one, we see that the expression is already in expanded form, so we have to use the properties of logarithms to condense it as much as possible. All right, so let's look at this expression here, the first term, so to speak. So for the first term, we have 1/3 times log base 4 of x minus log base 4 of y. Now, I'm first going to look at what is within the brackets, all right? So we see that both these terms, log base 4 of x and log base 4 of y, have the same logarithmic base, correct? And when that happens, then we can use the property. In this case, it would be the quotient rule property, because there's a minus in between the two terms. All right, so we are going to write it as 1/3, keep the 1/3 as is for the time being, and then log base 4, and then x and y will be written in quotient form as x divided by y. And just to make things clear, just surround it with brackets. All right, so we got 1/3 log base 4 times, log base 4 of x divided by y. And then plus, I'm going to keep this expression as is, log base 4 of x plus 1. All right. Now, keep in mind that x plus 1 is a unit. We cannot just go and distribute log base 4 and write it as log base 4 of x and then log base 4 of 1. No, that's not permitted. X plus 1 is a unit. It's surrounded with brackets. It has to go as a unit. All right. Now, in the next step, what I'm going to do is we have this log multiplied by 1/3 in the first term and multiplied by 2 for this second term. All right. Now, when that happens, when there is multiplication involved, we can use the power rule and write this multiplicative as an exponent. So I'm going to write it as log base 4 of x divided by y raised to the 1/3 plus log base 4 of x plus 1 squared. Okay. So now we have log base 4 of x over y to the 1/3 plus log base 4 of x plus 1 whole squared. Take another look now. We have again two terms. Both the terms are logarithmic terms and they have the same base. So we can apply the product rule once again for x divided by y 1/3 and x plus 1 whole squared and write it as in product form. So it's going to be 1 log base 4 and then x over y 1/3 multiplied by x plus 1 whole squared. Now you can either leave it like that, or if you wish you can rewrite the x divided by y to the 1/3 as cube root of x divided by y, all right, times x plus 1 whole squared. Okay, and that would be the completely condensed form of the expression. Now question number 2 is about solving various kinds of equation in the exponential or logarithmic form, right? The first one we have here is 4 raised to the power 7 minus 3x. So the entire expression 7 minus 3x is the exponent, and on the other side of the equal sign we have 1 over 16. Now recall that when solving exponential equations, your first goal must be to get the two sides to the same base if possible. All right, if we can write all the terms with the same base, then we can just make the exponents equal to each other and solve for x. All right, so here we have 4. I'm just taking on my pen here. We have 4 raised to the power 7 minus 3x as the exponent, and let me rewrite this. 7 minus 3x. And then the equal sign, and on the other side of the equal sign, we have 1 over 16. Now, 16 can be written as 4 squared, correct? We can rewrite 16 with base 4 in exponent form. So 16, I'm going to write that as 4 squared, right? Now, there's nothing we can do to 4 raised to the power 7 minus 3x on the left-hand side. That will remain as is, but we will need to do some more manipulation with 1 divided by 4 squared. We want to remove 4 squared from the denominator and bring it to the numerator. The way of doing that when we have exponents is to write it as a negative exponent. Now, because the denominator, the exponent is in the denominator, to bring the 4 squared to the numerator, we will need to write it as with a negative exponent. So this is how it's going to look. 4 raised to the power 7 minus 3x on the left-hand side, no changes there. And then 4 raised to the power negative 2. What negative exponents do is it flips the numerator and the denominator. So 4 squared goes to the top, but with a negative exponent, and the 1 will come down to the denominator. Now, because it's a 1, it will not make a difference to the value, so I'm going to just erase this 1. All right, but essentially the negative exponent will switch the numerator and the denominator. All right. So now we have the two sides with the same base. So we can just work with the exponents and write it as 7 minus 3x equals negative 2. Just work with the exponents, all right? We can ignore the 4 for the time being. So we have to solve for x. It's a simple equation at this point. So isolate the x by moving the 7 over to the other side. So we'll have minus 2 minus 7. So minus 3x equals negative 9. And if you divide both sides by negative 3, we will have x equals positive 3, correct? So we got a solution for 3, but I just want to go back and check, do a test to see if 3 is works for this equation. So I'm going to go back to the original equation, plug in 3 where there's an x, and see if both sides are equal or not. So let's do the test. All right. So 4 raised to the power 7 minus 3 times 3 is 9, correct? 7 raised to the power negative 9 equals, we have 1 divided by 16. So let's see, we have 4 raised to the power 7 minus 9 is negative 2, which is which again is a negative exponent. Therefore, we can rewrite this as 1 divided by 4 squared. All right, so a negative 2 means, as an exponent, means we rewrite this as 1 divided by 4 squared, which is equal to 1 divided by 16. So both sides are equal. Therefore, x equals 3 is indeed the correct answer. Now, question number 2 is about solving various types of exponential and logarithmic equations. The first one given here is 4 raised to the power 7 minus 3x equals 1 over 16. So this is an exponential equation, and the first goal that we must have when solving exponential equations is to try and rewrite them with a common base. Rewrite them with a common base. So here we have 4 raised to the power 7 minus 3x. On the other side, we just have 1 over 16. So let's see if we can rewrite 1 over 16 with a common base of 4 to match what we have on the other side of the equation. So I'm going to write 4 raised to the power 7 minus 3x equals, now 16 we can see can be rewritten as 4 squared, correct? So we will have 1 divided by 4 squared. However, the 4 squared is in the denominator. In the next step, we will try to bring the 4 squared over to the numerator so that it's at the same level as 4 raised to the power 7 minus 3x. In order to do that, in order to bring the 4 squared up in the numerator, we are going to use the rule of negative exponents that we had learned before. All right. So let me review that quickly on the side. If we have, for example, x raised to the negative 1, then what this means is, it means negatives are just reciprocal. All right, so this can be written as 1 divided by x to the 1. Likewise, if we have 1 divided by x, with x in the denominator, then when it's just x, that means the exponent is 1, correct? We can rewrite this as x to the negative 1. All right, so what happens is this positive exponent in the denominator will become negative when we take the reciprocal, or when we flip the numerator and the denominator, correct? We are going to use the same idea to bring 4 squared over to the numerator. So we have to rewrite the exponent with a negative exponent, and that will make sure that 4 squared moves to the numerator. So what's going to happen is, we on the left hand side we'll have 4 raised to the power 7 minus 3x equals 4 raised to the negative 2, correct? And now that we have the same base on both sides and both these are at the same level, we can just make the exponents equal to each other and solve for x. So we'll have 7 minus 3x equals negative 2. Just work with the exponents, and you can ignore the base for the time being. And this is a simple equation. We have to solve for x, so isolate negative 3x first by bringing 7 over to the other side. So we'll have negative 3x equals negative 2 minus 7, therefore negative 3x equals negative 9. So x equals, when we divide both sides by negative 3, we will have 3 as a value of x. Now, we do have to go back and test this value on the original equation and see if we are getting an answer of 1 over 16 before we declare this as a solution. So I'm going to take, let me write here, test. This is, I'm testing here. 4 raised to the power 7 minus 3 times 3. You have to plug in 3 into x. And so 3 times 3 is 9. So 7 minus 9, what is it equal to? 4 raised to the 7 minus 9 is a negative 2. All right. So it matches what we got here. And 4 raised to the negative 2, when we flip the numerator and the denominator, is going to be 1 divided by 4 squared. When I switched the numerator and brought it down to the denominator, the sign of the exponent will change and we will have 1 over 16. So both sides are equal to each other. Therefore, x equals 3 is indeed the correct and verified solution. So part B is 64 raised to the power x equals 1 divided by square root over 4. Now this problem can be solved in 2 ways, and perhaps I'll show both ways to you, but let's see. The first goal is to get both sides in exponent form and then rewrite the exponents with a common base if possible, and then we can just equate the two exponents and solve for x. All right, so we have 64. Okay, we have 64 raised to the power x equals, now on the other side we have 1 divided by square root over 4. So I'm going to write that 4 in exponent form. The square root, the radical, can always be transformed and rewritten in exponent form, and because it's a square root, it's going to be 4 raised to the power half, correct? Now the next thing is to write the 64 with a base 4, right? So think about it. 4 times 4 times 4 is 64, isn't it? 4 times 4 is 16. 16 times 4 is 64. So that means 4 cube, right? This 64 can be rewritten as 4 raised to the power 3, or 4 cube, raised to the power x equals, now we have 4 raised to the power 1/2 in the denominator. We want to move it to the same level as 64 raised to the power x. So we have to move it to the numerator, and like we saw before earlier, to switch from denominator to numerator, we will have to change the sign of the exponent. So if we write 4 raised to the negative 1/2, then we have moved it to the numerator, and of course the 1 can come down, but we don't need to show the 1 because it will not make a difference to the value, right? So let's see, now we can further simplify this by using the power rule on the left hand side. We have 4 cubed raised to the power x. So with the power rule, we have to multiply the two exponents and write it as 4 raised to the power 3x equals 4 raised to the power negative half. All right, so we have the same base now. We can just make the two exponents equal to each other and then solve for x. So we have 3x equals negative 1/2. So we can just divide both sides by 3 and we will have x equals, now this is fraction division, so what do? It's minus 1/2. Change the division to a multiplication and flip the numerator and the denominator of the denominator. So 3 means it's 3 over 1, correct? So when we flip the numerator and the denominator, it's going to be times 1/3, which is x equals negative 1/6, correct? We could either solve it this way. Of course, you have to go back and test though. We'll do it at the end. But initially I said we can solve this 2 ways. Both should give the same answer. So let's solve it in the other way, where we have 64 raised to the power x. So 64 raised to, so let me write method 2. All right, 64 raised to the power x. Now square root over 4 on the other side can be written as 1/2, correct? Now we can write 64 with base 2. All right, earlier we wrote 64 with base 4, but this time, since we have simplified 1 over square root over 4 and written it as 1/2, we have to see if we can write 64 with base 2. So we will have 2 raised to the power, now 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So it's 2 raised to the power 6 equals, now 2 raised to the power 6 raised to the power x. All right, don't forget that, because we have just rewritten 64 as, and let me just clean it up a little bit, because 2 raised to the power 6 raised to the power x. On the other side, we have 1/2. We have to bring the 2 in the denominator up to the numerator level. So that would be 2 to the negative 1, correct? This is like 1 divided by 2 to the power 1. And when you flip the numerator and the denominator, the exponents will change signs. It will be 2 to the negative 1. So we have 2 to the power 6 times x equals 2 to the power negative 1. So now we can make both the exponents equal to each other, and we will get x equals negative 1/6, which matches the answer we got by our previous method. All right, so now I'm going to go and substitute this negative 1/6 into x and see if we get 1/2 or 1 divided by square root over 4. So 64 raised to the power negative 1/6. All right, let's see what that is equal to. Now remember, I said negative means we can switch the numerator and the denominator. It will be 1 divided by 64 raised to the 1/6, and then we will have, which is the same as writing 1 divided by the 6th root of 64, which should be 1/2. All right, so that matches with what we got here. For question number C, we have e raised to the power x plus 4 equals 1 divided by e to the 7th. Okay, so we already see there are exponents on both sides with the same base of e. However, we will just have to switch e to the 7th up to the numerator using the rules of exponents. All right, so the left hand side is going to be written as e, and I always like to surround the expressions in brackets. So e raised to the power x plus 4 equals, to bring e to the 7th up to the numerator, we will just switch the sign of 7 from a positive to a negative. All right, so it's going to be e raised to the power negative 7. So since both the bases are the same now, we will just make the exponents equal to each other. X plus 4 equals negative 7. So x is negative 7 minus 4 is negative 11. All right, so that's going to be the solution. For question number D, log base 5 of x plus 3 equals 2. We will be applying the method of changing this or rewriting this in exponent form and then solving for x. So we will have the base as 5, which is the base of the logarithm, is also going to be the base of the exponent. And remember, the other side of the logarithm has a value which is really the exponent. All right, so the 2 is going to be the exponent of 5, and x plus 3, which is also referred to as the argument of log base 5, goes to the other side, is the evaluated value from the exponent. So it's going to be x plus 3. Now we have to solve for x in this equation. So 5 square is 25, and then we have x plus 3. So x will be moved the 3 over to the other side, and we'll have 25 minus 3 equals x. So x will be equal to 22, right? Now to solve question number E, we see that this is a logarithmic equation, and on the left hand side we have 3 terms. All of them are logarithmic terms and they all have the same base. So log base 3, and then in the second term also has a log base 3, and then the third term also has a log base 3. So we have log base 3 of x plus 6 plus log base 3 of x minus 6 minus log base 3 of x equals 2. So the left hand side, since it has logarithms in all the terms, and all of them are the same base, we can compress the left-hand side and write it with a single log, right? We have plus between two terms, so that will involve the product property, all right, of logarithms. And then the last term has a minus, so it'll involve the quotient rule, all right? So let's start working on it. We are going to start with log base 3. And then for the first two terms, since there is a plus, that would imply the product rule of logarithms, right? The product rule. So it's going to be log base 3, then x plus 6 times x minus 6. And then there's going to be a denominator because of this minus. Just a second. Let me get this to work. Because of the minus in the third term, we have to apply the quotient rule. All right, this will involve the quotient rule. That means this x is going to be in the denominator. So this is one whole expression with a single logarithmic term. So we have condensed 3 terms into a single term on the left-hand side. The other side is equal to 2, right? Now what we should do is, in order to solve this, we will have to rewrite this whole expression in exponential form. So let's do that. The base of the logarithm is 3. So 3 will also be the base of the exponent. And then this 2 on the other side of the equation is going to become the exponent of 3. And this entire x plus 6 times x minus 6 divided by x is going to go on the right-hand side of the equal sign. So it's going to be x plus 6 times x minus 6 divided by x. All right. So now let's try to simplify this. 3 squared is a 9. All right. 3 squared is a 9. Now x plus 6 times x minus 6, we can rewrite this as a difference of squares, right? Difference of squares. So when we apply the difference of squares formula, we just write that on the side in case you need to review it. It's a plus b times a minus b. If you multiply this out, you will end up with a squared minus b squared. So we have x plus 6 and x minus 6. So we can just square the two terms and put a minus sign in between them. So it's going to be x squared minus 6 squared is 36 divided by x. All right. So now let's continue simplifying this. We can cross multiply 9 and x, and we will have 9x equals x squared minus 36, right? So how did I get this 9x? You can either cross multiply, or to remove the denominator, you can multiply both sides essentially, right, by x. So that's what I did. All right, so now we have 9x equals x squared minus 36. Clearly, this is going to be a quadratic equation. In order to solve a quadratic equation, we have to make one side equal to 0. So if I move the 9x over to the right-hand side, we'll end up with 0 equals x squared and then minus 9x minus 36. So now we have to solve this quadratic equation. This is factorable. So what are the factors of negative 36 that will add up to a minus 9? It's going to be x minus 12 and x plus 3. All right. So when you factor this, you should come up with two factors, x minus 12 and x plus 3 equal to 0. Now make each factor equal to 0 and solve for x. So we have one solution as x equals 12. The other one is x plus 3 equal to 0. Therefore, x equals negative 3. However, even though we have two solutions, let's see if they satisfy the original equation. Remember, when there is a log base 3, this x plus 6 should be a value greater than 0. All right, it should be a value greater than 0. So when we plug in 12, so I'm doing a test first, a verification first with 12. So log base 3 of x plus 6, so 12 plus 6 is 18, so we are good. Log base 3 of 12 minus 6 is a positive value, 6, minus log base 3 of 12, that's positive 2, equals 2. If we plug in negative 3, then we'll have negative 3 plus 6 is going to be a positive 3, which is fine, it's positive. However, look at this, log base 3 of x minus 6. So minus 3 minus 6 is going to give us a negative 9. So that itself makes this invalid. So x minus 3 is not going to be a solution, because when we plug in minus 3 into this term, in the second term of the equation, we end up with a negative value, and that cannot happen. All right. So our only solution is x equals 12. That's the only solution. All right. Now the equation in question F is similar to the one in question E, where we have on the left-hand side two terms, both of which are logarithmic terms, and they both have the same base of 8. Therefore, we can condense the left-hand side into a single term using 1 log base 8, right? So that's what I'm going to do. I'm going to write log base 8 to start with. And then we have a minus sign between the two terms, so that would imply we have to use the quotient rule, correct? So it's going to be x plus 2 in the numerator and this x in the denominator. Okay, and on the other side we are going to have the 2. So now that we have a single term on both the sides of the equation, we have to write this in exponent form. So we have to change the logarithmic expression, the entire equation, and rewrite it in exponent form. So the base is 8 for the logarithm, and it's going to be the same base for the exponent. And this 2 on the right-hand side of the equation is going to become the exponent of 8. And this entire expression, x plus 2 divided by x, is going to go on the right-hand side of the equation. Okay, so 8 squared is 64. And then we have on the right-hand side x plus 2 divided by x. Now, I just want to mention an important thing here. This is x plus 2. Please surround it with brackets and treat it as a single unit, because the tendency can be to quickly divide this x and this x. That is not allowed, all right? You cannot do that. It's x plus 2 is a single unit, so you cannot divide terms, all right? You cannot cross out terms. You can only divide factors, and x plus 2 is a single factor, all right? If you have to divide, it has to be x plus, you have to divide it by x plus 2, all right? So if you surround it by brackets, it reminds you that this is a single unit, and we cannot just divide the individual terms of the expression x plus 2, all right? But let's proceed with solving for x. We have to get rid of the denominator, x. So I multiply both sides by x, all right, and get rid of the denominator on the right-hand side. And we end up with 64x equals x plus 2, correct? And now we can solve for x. So 60, get all the x terms on one side. So we will have 64x minus x equals 2. So this is 63x equals 2. Therefore, x is 2 over 63. All right.